So for question 5, we've got a hypothesis test to do. So the hypothesis test, they originally had a mean of 2.5, so we'll have lambda is 2.5, and the alternative is whether or not there's been a change. So it does not equal 2.5. We're doing a 5% test, and so we'll divide that by 2 because we've got 2.5% at each end. And what are we doing? We are doing this over a 3-month period. So actually the mean is lambda times 3 months. So we're looking at 7.5. We're looking at Poisson of 7.5. Under H0, X is a Poisson 7.5. And let's see what we're going to get at the lower end. So distributions. Poisson distribution, less than or equal to 7.5. Now 1's too small, so 0.025 there. So less than or equal to 3 gives us 0.0591. That's too big, so we'll change it to a 2. The probability that X is less than or equal to 2 is 0.202. 20256. 7. So at one end we're going to go less than or equal to 2. Let's go at the other end. So the upper end, so put that there. Let's change this now to a greater than and a 0.025 there. And so the probability that X is greater or equal to 13 is 0.0426. That's too big. So we'll go to the next one. The probability that X is greater or equal to 14 is 0.0215. It's the wrong one. Oh, sorry. I just went to push that. Oh, it's all gone horribly wrong now. What am I doing? There I am. All of that just so I could see this value there. 0.2156646. So what is my critical region? My critical region is X is less than or equal to 2 unioned with X is greater than or equal to 14. There is my, you should state the probability in each tail. I've done that as I've done it, didn't I? Part B, state the probability of a type 1 error. The probability of a type 1 error is the probability of rejecting H0 given that H0 was true. And that's these two values that we've just got. So if I just add those two things together, that gives me 0.04182, so 0.0419. Or 418 actually, mine's more accurate, is the probability of a type 1 error. So going on to part C, and we've now got data from 3 monthly periods for 2 years. Another one of these fun bits where you've got to try and figure out how many is that. And so that is 3 months for 2 years. That is 8 3-monthly periods. And the probability of having a significant result is that value there, isn't it? 0.0418. So what are we counting here? X is periods with a significant result. And we want to know that the probability of at least 2, so the probability that X is greater than or equal to 2 of those ones there. So into my binomial calculator, greater than or equal to 2 out of 8 with the probability that we just worked out there, I've got 0.0413. And looking at that more accurately just off the camera is 4139, so I'll change it to 0.0414. Mark scheme there's got actually a range of values now because there's so much rounding could have gone on in all the different places here. Has it got that? So the last part of the question says, given that the number of accidents per month was actually 2.1 per month, so 2.1 per month, find the probability of making a type 2 error. So X is actually a Poisson with a mean of, because it was 3 months, wasn't it? So actually 6.3. And the probability of a type 2 error is accepting H0 given that H0 was false. So that is the probability of, so the opposite of that one there. So going from 3 all the way up to 13. So from 3 to 13, we wouldn't have rejected it, would we? Given that it's a Poisson with a mean of 6.3. So I think we can do that all in one go, can't we? So let's get into the right menu here. We're a Poisson menu here. We want between two values. We want between 3 and 13 with a mean now of 6.3. And that gives us 0.9446, which is 0.945 is the probability of the type 2